Next, we're going on with the example 2 for reciprocal functions. So if let's say you are given a reciprocal function is such that fx equals to x plus 2 over x minus 2. So how we happens to get the answer here done if you ask to sketch the graph? So guys and girls, so in here, I make use of the knowledge if I happen to do long divisions, I will happen to convert the function fx in the form of 4 over x minus 2 plus 1. Kalau saya pakai long division. So the idea of long division, you happen to learn in chapter 6 later in polynomials. So after I can get this form here, then this form is corresponding to the form of reciprocal function that I have, where I have a over mx plus c, where my a is referred to 4, m is referred to coefficient of x, which is 1, c is minus 2, k is 1. So I have identified that it fulfills the requirement of the type of function we need. Then we proceed further. We like to determine the shape. So what is the shape that we should have in this case here is that we're going to make use of the value of a and the value of m, which is the coefficient of x. I find out that when the time I divide the a and m, I find out the answer is equals to 4. So therefore, I have the case of greater than 0. Therefore, the shape of graph, it will happen to be this situation. Okay, go on. The next thing what we happen to do is that now we go for step 3. So once again, step 2 here. When the time I notice my a divided by m is greater than 0, that means I'm going to have my graph at the first quadrant and also the third quadrant, where I consider the first and third quadrant based on the asymptote I have. Next, I want to decide the special line here, not special point, but instead, I would like to refer to special lines here, where the special lines here is referred to the vertical and horizontal asymptote in our graph. And how we decide the vertical and horizontal asymptote? First, vertical asymptote, refer to x minus 2. Make it equal 0. We have x equals to 2. So this will contribute to our vertical asymptote. Then for horizontal asymptote, refer to the constant plus 1. So it will go for the answer for the horizontal asymptote. Then as a result now, with this answer of the vertical and horizontal asymptote, we are able to go for the next step to decide whether our x and y intercept exists or not. And also, by right at this moment here, you can decide what is the domain and range. So when the time I want to decide domain of this function here, kalau you tengok, it seems like domain is referred to what are the x value I can take, or in graph, in terms of graph, how far it can travel horizontally when the time you extend the graph. You notice that when the time we extend the graph horizontally, it can pass through any x value except r equals to 2. So therefore, the domain I have is infinity until 2, but not include 2, union 2 until infinity. So there's a gap there at x equals to 2. Similarly, for range, you find out that if you extend the graph, it can go through any y value except y equals to 1, and therefore I have the range as this form here, where I have a gap at y equals to 1. Okay, then continue. So this is just extra thing like if you want to determine domain and range, reach until third step. Now next we continue on step 4, where we want to decide whether the x and y intercept happen to exist or not. So by using the asymptote that we have and the form of graph that we have so far until step 3, when the time you do the rough sketch, this is what I suppose I have lah. The vertical asymptote x equals to 2, horizontal asymptote y equals to 1, and I do the rough sketch of the graph, I should see that I can have x and y intercept exist. But once again, Whether is it located like what we have in the rough sketcher, that is another story that we need to verify by calculation. So in here, we know x and y intercept exist. Further calculation to verify the location. So to calculate the y-intercept, I let x equal to 0. I find out that y equals to -1. So once again, the rough sketch ada silap, tapi tak apa. Yang penting rough sketch untuk tahu wujud ke tidak the y and x intercept saja. Kalau wujud, kita kira untuk verify further. X-intercept, we let fx equals to 0 or we let y equals 0. I get x equals to -2. And once again, the rough sketch ada kesilapan. Tapi tak apa. Make use of this resultant value that we calculate for x and y intercept. Now, we combine with the rest of the information. We have our graph sketch as follows, where this is the correct position of our y and x intercept. And once again, reminder, things that you need to take notes. Make sure you label the x and y axis. Label the origin. Sini saya tak dapat label dengan jelas. Kalau you ada situasi yang macam saya, tak dapat letak kosong itu, boleh abaikan dia lah. Tapi kalau nak letak juga, cari tempat untuk letak. Contohnya macam ini. Then, label the graph, which is the function f. Label the y and x intercept. If let's say they exist, label the asymptote, the important line. So, buat dotted line dan juga label the dotted line. Therefore, this is how we happen to sketch our graph for the reciprocal function in example number 2.